Hi, so today we're still on ionic bonding or what we call electrovalent bonding. So I'm going to recap what we've done earlier. I said the reason for bonding is so that these elements will be able to attain a stable state. Normally, these elements occur naturally and they do not attain this stable state. But then these elements within a short period of time they quickly bond with each other or bond with other elements to form a compound or a molecule. The reason being that um, they are not in a stable state yet and they are doing everything possible to attain that stable state. And this stable state or configuration is called the octet rule or the duplet rule. And then, as mentioned earlier, I'm still going to be explaining the electrovalent bonding or what we call the ionic bonding. And what does it um, what happens in ionic bonding or electrovalent bonding? This is what happens. It's the bonding between metal and non-metal. Metal transfer or donates electron to non-metal and non-metal accepts. Okay? And then we know we have they say like charges repel while unlike charges attract. What it means by that is that when we have two charges that are negative, they will usually do what? Repel. They will not bond. These two will also do what? Repel. Okay? But these ones do what? We attract each other because they are like charges. But then, please don't get it twisted. Positive can actually positive can actually bond with positive. But that's explanation for another day. So I'm going to give us another example here. The example I'm giving here is magnesium and then chlorine. Previously we did magnesium and oxygen. So here we're going to draw magnesium. So this is 10, remaining 2. This is a magnesium atom. So we draw chlorine. So this is chlorine. Now, as mentioned earlier, the one with two electrons rather, we prefer to lose the 2 electrons than gaining 6 electrons. Reason being again that the energy required to gain those 6 electrons is far greater. But then the energy required to lose this electron is lesser. So it will prefer to lose these 2 electrons. In this case, it is just remaining only 1 for it to be complete. For it to complete 8 electrons, that is the octet configuration. Now, the energy required to gain 1 electron is very, very small compared to the energy required to lose the entire 7 electrons. So it will prefer to do what? To accommodate 1 electron, right? To become 8. But then, in this case now, if magnesium reacts with this one, bonds with this one here, if it donates this 2 electrons, chlorine only requires what? 1 electron for it to be what? To attain this octet configuration. So where will this one be? Now this then we now open the next topic for us. When we talk about balancing of chemical equation. So let's go. We're going to draw it now. Now, what it means that this one will be related to this, right? And it will remain one, right? So let's draw. Okay, it will remain one. But then, if it will remain one, where is this one going to? What it simply means is that we're going to draw another chlorine. So, in order not to confuse ourselves, it's better I explain it this way. So, we have, this is chlorine, this is chlorine. One of these electrons will go here, one of these electrons will go here. I think that is very, very explainable, self-explanatory now. So now, if these two electrons has gone, one has gone here, another one was gone here, what it simply means is that we will clean this outer one and it will remain the two inner ones. So we have two electrons at the outermost shell. Two electrons first. So we have this. It has attained the octet configuration, which has always been its prayer. Now this one will also attain its own octet configuration too. So we have it this way. So you remember this one here, this is the one, okay, this is the one is accepting, okay, so it has maintained attain this octet configuration. This one too also accept this one too. Okay, let's say this one is for this, okay, and this one is for this. So we have the other one here, making it 8. So you can see. So what we want to draw, what we want to do is to say magnesium plus what? That is how many magnesium? 2 magnesium. Sorry, 1 magnesium rather. Magnesium plus how many chlorine? 2 chlorine. Chlorine atom. Giving us what? Magnesium chloride. This is how it is being written. Alright? So we have 2 chlorine, 1 magnesium. This is 2 chlorine, 1 magnesium. Reacting together or bonding together to form what? 1 magnesium and 2 chlorine. This is how it is written. Okay? So if I to write again, you can see magnesium lost what? We have it lost what? 2 electrons. Right? While chlorine gained what? 2 electrons. Chlorine gained 2e minus. Gained what? 2 electrons to form what? Chlorine.